For this part, we were asked to fill in the table using these two triangles with these exact measurements. With referring back to them, here we were asked to find sine, cosine, tangent, secant, cosecant, and cotangent. Sine was opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, secant hypotenuse over opposite, cosecant hypotenuse over adjacent, and cotangent adjacent over hypotenuse. So sine, cosine, and tangent, and secant, cosecant, and cotangent are the opposites of each other. So moving on here. So asked to find the measurements of these two triangles. Throwing into here. So basically all I had to do was plug it in. So first you'd find the sine of the triangle, which would have been here 5 over 10. So here we would write 1/2 y because 5 over 10 simplifies to 1/2. So here, throughout the table, you'd have to simplify, which is why we have a lot smaller numbers than normal. So first one would be 1/2. Going on to cosine, it'd be technically 5 root 3 over 10, which would be simplified into root 3 over 2. Going on to tangent is root 3 over 3, which was originally 5 over 5 root 3. Cosecant would be 2, because you were asked to find the hypotenuse over adjacent. Secant would have been 2 over root 3, which you have to simplify into 2 root 3 over 3 because square root can't be in the denominator of a fraction. Leaving cotangent to be root 3, because we have to keep referring back to these two triangles here. Moving on to the 45 degree, it would be 3 over 3 root 2, which would all simplify to root 2 over 2. Cosine would be root 2 over 2, and tangent would be 1. So notice how the first three, so sine, cosine, and tangent, and cosecant, secant, and cotangent, are all the same, just flipped. Just like over here. Sine, cosine, and tangent are the opposites of secant, cosecant, and cotangent. Moving on to the 60-degree triangle, it would be 5 root 3 over 10, which would simplify into root 3 over 2. Cosine would be 1 over 2. Tangent would be root 3. Cosecant, 2 root 3 over 3. Secant, 2. And cotangent, 3 over 3. So in the triangles, x would equal 10, the hypotenuse would be 10, or x would equal 5, hypotenuse would be 10, and this length right here, 5 root 3. Here is y equals 3. This side right here is 3, and the hypotenuse is 3 root 2.
The sine graph. The shape of the sine curve forms a regular pattern as the wheel goes round once, and then the curve will repeat. The curves are periodic, and that means it is the time it takes to go through one complete cycle. The amplitude of the graph is the way the graph will look, the little bumps. This is a cosine graph. Cosine graphs are similar to sine graphs, just cosine graphs start at y equals 1 and sine graphs start at y equals 0. A cosine graph is the same thing as a sine graph, it is just shifted to the left more. An example of a cosine and sine graph relating to real life is music. When you play a note with an instrument, it sends out different frequencies and amplitudes.
More intense, bro. They're not that bad anymore because I think it's way more intense.
A filled-in unit circle. It goes around all the way to 360 degrees, and it's divided in 3 triangles in each fourth of the whole triangle. And there's degrees for every angle, and there are coordinates for every line and point on the outside of the circle. There's a number in terms of pi as well. And each quarter has their own positive or negative. Circle is also used to measure curves or anything that is circular.